Okay, moving right along with area formulas and finding areas of two-dimensional figures. We are in the coordinate plane today. Sometimes, especially on standardized tests, they like to give you questions that are seated in where we have figures seated in the coordinate plane. Sometimes they give you the picture already drawn. Sometimes you have to draw your own, which is what that blank do your figuring space is for. So draw the picture and use the formulas that you know. Now, again, you can get by with just rectangle parallelogram formula and triangle formula. It will do everything. So we're going to bank on those formulas today to get the areas of all the polygons on this page that are in the coordinate plane. Now, you really could count squares. So if I wanted to find the area of the figure in this first picture, I could count squares because each of the little squares in this picture, since we're counting by 1 on the x and y axis both, each of these squares is 1 square unit of area. So I could count all the squares. That's time consuming. I don't have time for that. So I'm going to roll a different way. This is a rectangle. And I know the area of a rectangle is base times height or length times width. So why don't I just find the lengths and the widths of the sides? So let's start with the bottom. We'll call that the base. It has a length of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 units wide. The base is 10. You could also find the distance between the x-coordinate of -6 and the x-coordinate of 4, and the distance between -6 and 4 is 10. And then we need to multiply by how tall it is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is the height. Or we could do, what's the difference between -3 and 8? And that's 11. 10 times 11 is 110 square units. Done. That is faster than counting all the squares in the figure. Even though it would work, the more efficient method is your time saver. Alright, number the next one. Number 2, we have a triangle. There's a formula for a triangle. It says take 1/2 times the base times the height. This triangle is a right triangle, so it has a built-in base and height. The bottom can be the base. It has a length of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or you could do the difference between -7 and 5. Multiply, oh, I forgot the half. Let's squeeze that in. So it really doesn't matter where I put it. Times 1/2 times the height. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So times the height of 10. So half times 12 times 10. Well, half of 12 is 6, and 6 times 10 is 60. So 60 square units of area for this one. Okay. So on the next one we have a triangle that's turned around a little bit differently, so you have to work harder to get a base and a height here, but we're still going to use that 1/2 times base times height formula. If it helps, you can turn your paper this way and see this base. And the important thing is that you find a side that is on a horizontal or vertical line of the graph. Anything that's not on a horizontal or vertical line is going to have an irrational, quite possibly an irrational measurement, and it's going to be more difficult to compute. So if you can find a horizontal or vertical side that you can just count spaces, that's your ideal. So I'm going to turn it up this way and count across 1, 2, 3, 4, 5, 6. So that one has a length of 6, and then the height has to make a right angle with it, and that's the tricky thing here. So the height has to make a right angle. So I'm going to extend this over and then go right angle straight up to the opposite corner or the opposite vertex. So this is going to be my height. It's on the outside because it's an obtuse triangle. So it has a length of 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to turn it back around. I have a base of 6. and a height of 8. So my area is going to be 1/2 times 6 times 8. Half of 6 is 3. 3 times 8 is 24 square units. We have a kite, looks like on this one. So how about we divide it into triangles just like we did kites yesterday. So I'm going to draw a horizontal line from W to Y. I can count that distance really easily. 1, 2, 3, 4. So I have a triangle with a base of 4. The height is 1, 2, 3. So the top section is going to have an area of 1/2 times the base of 4 times the height of 3. Half of 4 is 2. 2 times 3 is 6. So the top section, area of 6. The bottom section, do that in a different color. Okay, it's an upside down triangle, so I'm going to use 4 as a base again. The height of this one is going to be 1, 2, 3, 4. So that triangle has 1/2 times the base of 4 times the height of 4 area. Half of 4 is 2. 2 times 4 is 8. Total area then would be 6 plus 8, which is 14 square units. Again, it might be possible to count squares and count halves of squares to get the areas of these. But generally the more efficient way is to use the formulas. So don't treat them any differently than what you did yesterday. The only catch is you have to count the squares, count spaces to get your measurements. Okay, 2 more. This time we have a parallelogram. Opposite sides are parallel on this one. And a parallelogram has a formula base times height for the area. So I need a base and I need a height. Now these diagonal sides on the top and bottom, those are more difficult to measure because they aren't horizontal vertical measurements. So maybe I should turn it around this way and let this side be a base because I can count that one. So 1, 2, 3, 4, 5 squares long, so that one has a length of 5. And then the perpendicular distance, the right angle distance from there to the opposite will give me the height. So I'm going to go straight up. 1, 2, 3, 4, 5, 6. And so I have a height of 6 that makes a right angle with a base of 5. Base has to be a side. The height never is in a parallelogram. So substituting those numbers in the formula, we get 5 times 6, which is 30 square units. And last but not least, that looks like a trapezoid. It's a little bit fuzzy, but we're going to roll with it anyway. We've got a couple of options. We could use the trapezoid formula, or we could use triangles and rectangles, which is what I prefer because then I don't have to memorize an extra formula. So I'm going to chop this up into a rectangle and a triangle. Alright, for the rectangle part, we have a base of 1, 2, 3, 4, 5, 6, 7, 8. And a height of 1, 2, 3, 4, 5, 6, 7. So its area is 8 times 7, or 56. For the triangle section, we have a base of 8. It's going to be the same as that bottom side was. And a height of 1, 2, 3, right angle between them. So 1/2 times 8 times 3. Half of 8 is 4. 4 times 3 is 12. If we add the two parts together, area equals 56 plus 12, which is 68 square units. Alright, so you're going to find the 10-4 practice problems in your packet and complete those, practice these, and we'll wrap up the last of the formulas with circles tomorrow.